All right, so let's take a look at these homework problems from Skill 10B. If the if it's a sine or cosine function, and if the coefficient in front of x is 1, the period is going to be 2 pi. If I look here, the multiplier in front of here is going to be the amplitude. And it's actually the absolute value of that. This amplitude and the period will always be positive values. The center line is what we're adding or subtracting to this the sine function or the cosine function, and it's a horizontal line, so it's y equals, and it's y equals 0. Make sure you write it as an equation. Now, the basic sine curve looks like this. Normally it's between 1 and -1, but we've stretched it to be between 4 and -4. It crosses this center line, y equals 0, which is the x-axis, here at 0 and at pi. So at x equals 0, plus any coterminal angle, and also here because the period is 2 pi. So x equals pi plus any coterminal angle. The maximum value, because we've stretched it, vertical stretch, is 4, and the minimum value is -4. On this next one, the coefficient in front of x is 1, so the period is 2 pi. The amplitude and period are always going to be positive. This multiplier, this is a vertical stretch. Now it's also a reflection. The center line, we haven't added or subtracted, we haven't lifted the graph up or pushed it down. So the center line is at y equals 0. Normally, our cosine curve looks like this. The 2 pi. But we've not only stretched it, we've reflected it. So let's extend this down. So this point that was at 1 is down here at -1. And this was at -1, and now it's up at +2. This was at +1, and now it's down here at -2. So it's crossing the center line here and here. Reflecting it didn't change that. Vertically stretching didn't change where it intersects the x-axis from the regular cosine curve. So it's crossing the center line, this center line at y equals 0 here at pi over 2. So at x equals, I'm going to shrink this up if I can. At x equals pi over 2 in any coterminal angle to pi over 2. It's also crossing it right here at 3 pi over 2 in any coterminal angle to 3 pi over 2. The maximum value is up at y equals 2, and the minimum value is down at -2. Maybe I should emphasize that the output of the function is the y coordinates. Alright. Since the coefficient in front of x is 1, and it's a sine curve, sine or cosine, have a period of 2 pi. The amplitude, this has been a vertical stretch. The 0.5 is 1/2, so I guess I'll just keep it as a decimal. I have a new center line, this +4. See, before my center line was +0. Now y equals 0, 0 plus 4, it's 4. All right, so this basic sine curve has been lifted up 4 units to where now, let's draw a dashed line. If this is the line y equals 4, then my sine curve is looking like this, and the amplitude is 0.5, is 1/2. So you're going up 1/2 and you're going down 1/2. So the maximum is y is equal to 4.5, and the minimum y is equal to 3.5. Sine crosses its center line. Since there's been no horizontal stretches or shrinks, it's crossing the center line at 0, and any coterminal angle to 0, and also at pi and any coterminal angle to pi. Cosine, again, we have a coefficient of 1. Sine and cosine will have a period of 2 pi. The amplitude is this multiplier out here. Both of these need to be positive values. The center line, however, it's a horizontal line, so it's always y equals, and it's whatever you're adding or subtracting. So -10 is my center line. So I know that my graph, if this, it's not +10, it's -10. So I've got my graph drawn wrong. If this is the line y equals -10, then, and 6 units above -10, if I add 6 to this, I'm up here at -4. And my graph is going to go like this for cosine, then come down here, then come here, and then come here. And that's one period. That pattern is going to continue. If I'm 6 units below -10, I'm down here at -16. So my maximum is y is equal to -4. My minimum, the lowest point, is y is equal to -16. It's intersecting the center line here and here. Well, this is 2 pi, and it's symmetric, so this is pi, half of 2 pi, and this guy is pi over 2, and this is 3 pi over 2. So it's intersecting the center line. It's crossing the center line at pi over 2 and at 3 pi over 2. Let's see, is it gonna, yeah. So where the max and min were y coordinates, the location of where it's crossing the x-axis here, these are x-intercepts. So at pi over 2 and any coterminal angle to pi over 2. So if you jump forward 2 pi or backwards 2 pi, you're going to land on the center line. If you're here at 3 pi over 2, the same thing. If you go forward revolutions or backwards complete revolutions, you're going to land on that center line. The coefficient in front of x is 1, and it's a sine or a cosine, so the period is going to be 2 pi. Out in front here, the amplitude is, a 1 is implied there, so the amplitude is 1. My center line is what I'm adding or subtracting. It's always y equals, so it's y equals this decimal number, -3.25. So if I sketch the graph of what this is going to look like, here's the line y equals -3.25. If an amplitude, if I'm 1 unit above that line or 1 unit below that line, that's my range for this cosine curve. So if I add 1 to this, this is going to be -2.25. And if I subtract 1, this is going to be negative 4.25. So my maximum is y equals negative 2.25, and the minimum, 1 unit below my center line, because my amplitude was 1, is negative 4.25. The shape of the cosine curve looks like this. And that pattern continues forever. So let's shrink this up. Yeah. This value on the x-axis right here is pi over 2, and here 3 pi over 2. So this point is pi over 2 comma negative 3.25, and this point 3 pi over 2 comma negative 3.25. So it's going to intersect, this graph intersects the center line at x is equal to pi over 2 and any coterminal angle to pi over 2. It intersects this center line at 3 pi over 2 and any coterminal angle to 3 pi over 2. There's my complete answer for number 5. For number 6, the coefficient in front of x is 1. It's a sine curve. If it's sine or cosine and that coefficient's 1, the period is going to be 2 pi. The amplitude is the multiplier out in front. Both of these numbers are always going to be positive because they're distances. My center line is an equation. It's a horizontal line for the sine and cosine, and it's always what I'm adding or subtracting. In this case, negative 3.4. So, if I think about what this graph is going to look like, my center line below the x-axis here at y equals negative 3.4. Since my amplitude is 1.8, I'm 1.8 units above that and 1.8 units below that center line. I don't want to make a silly arithmetic error late in the day, so if I take negative 3.4 and I add 1.8, then this maximum value is negative 1.6. If I take the negative 3.4 and I go below the center line, the length, the magnitude of the amplitude, below 1.8 units, then I'm down here at a minimum of negative 5.2. So this graph lies entirely between those two values. That's my range. My maximum was negative 1.6. My minimum is negative 5.2. The sine curve goes through the origin, so since that's been pushed down, it's here. So it's going to go up to the maximum, it's going to come back down to the center line, then it's going to go down to the minimum, then it's going to come back up to the center line, and it just continues to do that cycle forever to the left and to the right. So it's crossing, there has been no horizontal compression or horizontal shrink. So this is 0 and this is pi. So it's going to cross the center line at 0 radians and at pi radians and any coterminal angle to those. So at x equals 0 and any coterminal angle to 0 radians. At x equals pi radians and any coterminal angle to pi. Remember, n is just an integer, 0, plus or minus 1, plus or minus 2, plus or minus 3. So we're adding or subtracting complete revolutions, multiples of complete revolutions. All right, so they expect us to graph this. Let's graph the parent function, this cosine curve, in red. So it starts here at 1. It's going to come down at pi over 2 and for it cross the center line, because this center line is the x-axis. Then at pi it's down at negative 1. At 3 pi over 2 it's back up to the center. And at 2 pi it's back up to 1. And it's kind of curved and I just know that from experience. So this is one cycle, and I know that cycle continues forever to the right and to the left. So this is going to come here, 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 and here. So this next cycle is going to look like this, and that's going to continue on. And over here, the same thing. Here's the next cycle. It kind of curves in. And if I draw another, this is coming here. I'm listening to Bob and Tom show, so I'm doing this. All right, so there's my graph of the basic cosine curve. Well, what is the, the one in front of x there? Hey, nothing's going to happen in this period. It's still going to have a period of 2 pi. With a 1 here, it's going to have an amplitude of 1. It's going to be 1 unit away from the center line. But I'm going to have a new center line. Instead of the x-axis, this -3, my center line is going to move down here. Let's change color. I don't know what color I used. I used multiple colors to indicate the different periods. All right, so there's my center line at y equals 3, and it's this same graph. So this 1, it also got pushed down 3 units, and 1 minus 3 is a -2. Okay, and this point has a y equals 0 minus 3. 0 minus 3 is -3. -1 minus 3 is -4. All of these points, remember, are being pushed down 3 units. It's a rigid transformation. Here, this x-intercept, if you go down 3 units, you're on the new center line. This max of 1, if you go down 3, if you subtract 3, 1 minus 3, -2. So we have this for our new cosine curve. It's the same shape as the previous one. It just has this new center line at y equals -3. But nothing else has changed. It has the same amplitude. It has the same period. So it has this same general shape. The domain is still all real numbers. However, the range is now from -4 to -2 inclusive, right? These aren't just straight lines. They're kind of curved in there. We've seen that. All right, and then if I just do another one just to be complete. So there we have it. We've graphed the basic cosine curve, and then we've graphed this new function that got pushed down 3 units. All right, let's take a look at the next one. The basic sine curve. It goes through the origin. It has a maximum value of 1 and a minimum value of -1. It has a period of 2 pi. It kind of curves in like this. Curves in like this. There's one cycle. That cycle is repeated forever to the right and to the left. So it goes up to 1, back to the center line, down to -1, back up to the center line. That's one cycle. It's a periodic function. This period repeats itself. This comes down like this. If I do one more cycle, it goes down, back up the center line, back up the top, back to the center line. So here is my parent function, my basic sine curve. What I'm going to do to that now is a vertical stretch. It's going to stretch all the y values get multiplied by 2. So when these y values are all 0 because you're on the x-axis, you haven't gone up or down. And when I take 2 times 0, it has the same x-intercepts, but now all the y-coordinates get multiplied by 2. Here at this point the y-coordinate is 1. When you multiply it by 2, it's here. So this crest gets vertically stretched up to here. And this is -1. When it gets multiplied by 2, it becomes -2. So this gets stretched, vertical stretch there, where now the range of this thing is between -2 and +2 inclusive. See, these y values all get vertically stretched away from the center line, away from the x-axis. And you do have to kind of try to get used to freehanding it. If you won't be graded on whether your freehand is really, you have to be a little bit reasonable, try to make it a little bit curved, but it doesn't have to be perfect. So what I've sketched in black is this new sine function with an amplitude of 2 units above its center line, 2 units below its center line, has a period of 2 pi. We've done what they've asked. We graphed the parent function and we've graphed the new function that was a vertical stretch. So now this cosine, remember we already know what the cosine looks like. So my parent function is just bouncing back and forth between 1 and -1. And notice it happens pi/2 units apart. So my basic cosine function, which I'm treating as this parent function, has a range from -1 to +1 and has a domain of all real numbers. This pattern continues forever. I can't draw forever, so I put an arrow at the end of each of these to indicate that this pattern continues. Now, we have two transformations going on. We're going to lift it up 2 units, but we're also reflecting this across the x-axis. So I'm going to reflect it first. So what was up is now down, what was down is now up. So here's a reflection of my basic cosine curve. You can see the x-axis is a mirror. Alright, so I've taken care of this reflection. Now, this graph in red, I need to lift it up 2 units. So I don't know, let's make it in blue. So this center line that was at the x-axis is at y equals 0 has now been lifted up to y equals 2. And so every point on this red graph now gets lifted up 2 units. So oops, let's do it in blue. So if this point goes up 2, if this point goes up 2, if this point goes up 2, this point goes up 2, these points on the center line are now on this new center line, right? And this maximum is up here, y equals 1, but if you had 2, the new maximum is 3. And the new minimum, -1 plus 2 is +1. So I've got this guy's going like this, oops, like this. I thought something looked kind of goofy. Then I'm up 1, then I'm back to the center line, then I'm at my minimum, I'm back to the center line, I'm at my maximum, I'm back to the center line, I'm at my minimum, then I'm back to the center line. Do you see how it has a pattern? So this continues on forever. We reflected the graph across the x-axis. Then that graph that was the new graph in red got lifted up 2 units. So here, the basic sine curve goes through the origin, has a maximum of 1, comes back to the center line, a minimum of -1. It has a period of 2 pi, so this up and down continues forever. So it goes up, back to the center line, down, back to the center line. This comes down, here, here. So, and this is kind of curved in there, so you just kind of have to get used to doing that. Because it's not worth our time to create another chart when we know that basic. The whole reason of knowing the shifts and stuff is so that we don't have to get that detailed and making tables. Alright, so the negative sign is going to reflect it. The 3 is going to stretch it. I can do both of those transformations kind of at the same time. I can reflect it across the x-axis. So what was up is now going to be down at -1. But then when you multiply it by 3, it's going to be down at -3. So this point that is all these points that are the intercepts, as far as the -3 is concerned, are going to stay right where they're at. Okay, and this did go up 1. Now it's going to be reflected and stretched, so it's going down to -3. So I know that the graph is going to look like this. Then this has been reflected and then up to +3. So again, it's a little bit, it's difficult to draw on this thing with this wireless tablet, but I know for the first time you guys drawing it on your pencil and paper may not be the easiest either. So I'm not looking for a perfect picture. We're not going to hang it in a museum or anything like that unless you become really famous. Alright, so now this center line currently is the x-axis. I need to lift this up 1 unit. So let's see, let's do it in blue. So now this is like this, okay? So these points where it crossed the center line, it's still going to cross that center line. So this red point got lifted up 1 unit. This got lifted up 1 unit. This got lifted up 1 unit. See, these are all the points where it's crossing my center line. I'm just lifting it up. All these x-intercepts are getting lifted up 1 unit. Okay? So now this minimum, it's going to get lifted up 1 unit. So now my final graph, it looks like that. That maximum got lifted up to a new maximum. This minimum got lifted up to a new minimum. Now, let's stop and check here. This is our center line, and we're 3 units, our amplitude is 3 units up, and here to the minimum point, 1, 2, 3 units down. So this is my center line at y = 1, and that's shown here in the equation. So everything is looking good. It's looking a little bit sloppy, and on your paper I don't know how to help you if you just have a lead pen, if you don't have colored pencils. But like I say, it doesn't have to be necessarily perfect. But it does have to be perfect enough to get basic information from it. So there we go. My graph in blue is this new function. The graph in black was the original parent function, the sine function. I did a reflection across the x-axis and a vertical stretch at the same time. So a max of +1 became a min of -3. A min of -1 became a max of +3. That was the red curve. So that red curve was the result of two transformations, and then the +1 was just lifting that red curve up 1 unit. All right, hope that helps.